We are live, I guess. Hey everyone, I'm Suhag. I'll be your host for this session, and I hope you all are enjoying the third edition of TestMu so far. Today, we are diving into something pretty intriguing: the mix of chaos and order in our digital systems. So, we have Yusuf Tayman with us, who will walk us through this exciting topic. He'll show us how chaos isn't just something to control, but something we can actually use to build stronger systems. A bit about Yusuf. He's lead QA engineer on at OpenPayd and has spent 7 years pushing boundaries in observability and automation. He's expert in creating chaos scenarios with tools like K6 and turning those into valuable insights. We are going to explore the principles of chaos engineering. We will learn how to use K6 for fault injection, helping us manage and even embrace chaos in our systems. By the end of the session, you will have a solid grasp of how to handle disruption and maybe use it to your advantage. So, and yeah, we'll wrap this up with a Q&A session. So feel free to drop your questions in the chat. All right, I guess that was all from my end, Yusuf. Stage is yours.
Thank you very much. Thanks for a nice introduction. And let me share my
Sure.
screen. Probably you are seeing my screen right now. Okay, let's start then. Thanks for the great introduction again. Thanks for these great conference, and it's really glad to be here. And let's start. Today we will walk through with chaos and fault injection, and then I will demonstrate some real-world scenarios, an example with K6, how we can implement K6 into our systems, and finally we will do a grand final. In chaos, we find order. In failure, we find resilience. At first, this may sound a bit confusing, right? How can chaos lead to order? How can failure make us stronger? But if we think about it, this code speaks to something important about our life. Chaos, by definition, feels messy and out of control. It's when things don't go as planned and we feel lost or overwhelmed. But it's in those very moments when life feels chaotic that we are pushed to find new ways. Like, let's think about in the middle of the storm. We start to see patterns, create plans, and find solution we might not have seen before. Chaos, in a way, forces us to grow and forces us to improve and find order in the disorder. Now let's talk about the failure. Failure is something most of us try to avoid. It's kind of disappointing and sometimes embarrassing. But failure is also one of our greatest teacher. When we fail, we learn. We figure out what didn't work and we find the ways to do better next time. Each time we fail and try again, we build something important. We are calling this resilience. Resilience is the ability to keep going, to keep fighting, even when things get tough. It's all about getting up after we fall again and again. Now, let's remember the last feature your team deployed. Is it working? Right now? In production? So, how do you know? What if I told you it's not working as expected right now? What if there is a bug or an issue affecting our users right now? Do you have any tools or process in the place to catch it quickly? Can you respond and fix it before it causes real problems? So here is the some keys. Being proactive and prepared is the key. How do you ensure your team is ready for anything? Is our app ready to fit? I mean, is our ready to failure injection testing? Failure injection testing is a process where faults or failures are introduced into the system to see how well it can handle unexpected issues. So, failure injection testing operates some principle similar to the saying testing leads to failure. and failure leads to understanding. Our goal is not avoid the failure, but to cause it in controlled environment so we can learn from them. When we inject failures, let's imagine such as simulating a server crash, network outage, or a sudden increase in load, we are testing the system resilience. We need to ask some questions. What happens when things go wrong? By observing the system response, we are collecting valuable insights into these weak points, into the potential vulnerabilities, and we need to ask some questions how it can be improved. And through the failure injection testing, we intentionally create these situations where the system is likely to fail. These failures are not setbacks, but also opportunities. Each failure helps us understand how system behaves under pressure, how to prevent those failures from affecting real users in the future. In a nutshell, failure injection testing embodies the idea that by pushing our system to fail and understanding of our application limits, of our application capabilities, ultimately leading to a stronger, more reliable application. Before jumping to the test for the failure injection testing to implement our system, we need to walk through with some principles. First of all is the plan. You need a solid plan. This involves identifying the goal of our testing, the specific failures you want to inject, or the part of the system you want to test. Planning section ensure that the tests are focused and aligned with our objectives, whether it might be testing the system resilience to a specific type of failure, or understanding how certain component behaves under stress. And also, we need to ask some questions here. What are the critical components of the system? What type of failures are most relevant to our test? And what are the success criteria for this testing? The second one is experiment. Once the plan in the place, it's time to run some experiments. This also involves actually injecting the failures into our system as planned. For example, you might simulate a database outage. It might be a network delay or sudden spike in user traffic. The goal here is to observe how the system reacts in real time under controlled but realistic failure scenarios. So for this, we need to take some steps here. First, implement the planned failure injection, then monitor the system behavior closely during the experiment. This is important. And then ensure the experiments are repeatable and consistent. The third one is analyze. After the experiments are conducted, the next step is to analyze our experiment results. This is where you dig into the data to understand how the system handled the failures, and also did it recover as expected? Were there unexpected behaviors or app crashes? Analyzing these results helps you understand which areas you need to improve. And we need to focus some areas in here. First, look at the patterns and repeated failures, then compare the outcomes against the success criteria, and then final steps to identify any unexpected or critical issues. The last one is mitigate. After analyzing the results, we need to mitigate the issues you've uncovered. This could mean improving the system fault tolerance, adding better error handling, or refining your infrastructure, or for handling some failures more gracefully. Our goal for the mitigation is to reduce the impact of similar failure in the future, making the system more resilient and reliable. So we need to take some actions or consider some actions in this stage. We need to implement some fixes and improve. We need to improve some part of the system regarding to our findings. and we need to enhance the monitoring systems and alert systems to detect the issues faster. And also regarding to the some findings, we have to update the system architecture, or we need to update our code to better handle the type of failures tested in the experiment section. Now let's look at how we can implement failure injection testing to our system. We will use the K6 disruptor today, but you can use the 𝐘𝐮𝐬𝐿, Gremlin tools, or the other tools like AWS fault injection tools or Netflix failure injection tools. But today I will walk through with the K6. Let's briefly explain what K6 is. You may heard about K6 before. K6 is an open source performance testing tool and allow us to write and run some load tests to measure our performance and reliability of your system. Now, let me introduce the K6 disruptor. K6 disruptor basically one of the extensions for on the K6, and this extension designed for the system running in the Kubernetes, and this extension also offers us an API for injecting different type of faults into specific targets, such as pod, such as services. These faults can include injecting issues into HTTP request, or the other request type like increased latency or error responses. Now let's take a look at what we can do with K6. When we look at the anatomy of K6, we see that four structures. The first section is the option section. In this section, we can determine some scenarios, and we can select how much load we will put on the system, how many virtual user we are doing this load. And the other section is the setup section, where you can create test data, and you can call these test data. You create it in the test with a single parameter, which is data parameter, and the default function is part of the where we can write our test script. The tear down section, if you have written a test before, you are familiar with the setup and tear down section. In this section, you can delete test data which you have already created test data. Now let's look at the closer the how K6 disruptor works. K6 disruptor have two different disruptor. One of them the pod disruptor, the other one the service disruptor. When we want to test how our system handles problems like simulating a failures, the pod disruptor sends a message to the tools attached to each pod, and it tells them to create problem in their specific pod. Basically, the pod disruptor is like a manager that selects the right pods and tell them when and how to create issues, and helping us to see how well our system can handle those issues. Service disruptor also works as a wrapper around the pod disruptor, which targets the pods that backend the service. And service disruptor looks at the service you've defined when you set it up, and it then creates a way to find the pods that are linked to that service. And service disruptor basically creates a pod disruptor using the pod selector, and pod disruptor installs the agent again in the target pods. From this point, the pod disruptor works as described before. Now let's dive into a case study to better understand how development teams can use K6 disruptor. We will use the Success Shop demo application, which implements a microservices-based e-commerce site. And this application consists of various microservices, each with its own API. Let's imagine that the incident in the question was caused by long-running queries in the catalog service database, and resulting in delays and HTTP 500 errors, while the catalog service team investigating the root causes and the other teams wants to validate the resilience of their service to such as disruptions. So let's look at the catalog API. And as you can see, the catalog API, and here is the response. You can see the randomly getting products descriptions like description, image URL, price count, and it also response return us to the 200 status code. Now let's inject some failures. First, we need to import service disruptor module from the K6 extension, and then we need to add HTTP module, which is used for making HTTP requests. And this init code also defines the product keys that will be used when making requests to service. And we are writing here randomly the some products. Now, the other section is scenarios. Let's define some scenarios. The base scenario applies the test load to the our catalog service for 30 seconds for the set baseline. The inject scenario is executed after the 30 seconds of the test run. It also provides the inject faults function one time and injecting faults into the HTTP request of the catalog service. And the fault scenario is also executed after the 30 seconds of the test run, reproducing the same workload as the base scenario. But now under the effect of the faults introduced by the inject scenario. The request product function makes an basically API request for a random product, getting random product in the catalog using the some services with external API. And this service API will always return a 200 status code, regardless if the request was successful or not. So we need to add some check whether the response body contains an error attribute. We are adding the check section for the checking the response body. The inject fault function creates a service disruptor. So we will use the catalog service, and we are defining the service disruptor, and we are writing the selecting the catalog service, and the disruptor works by installing an agents to the pods and back this service. These agents also will intercept the incoming request and inject faults, and this test defines some faults. Like we are adding some delays, like 100 milliseconds to each request, and return 500 error code for only 10% of them. And the fault definition also specified the content of response body when an error is injected. And this fault is injected to the service for like only 30 seconds. When we run the test, we can see that for the base scenario, 100% of requests pass, and average request duration is 5.6 milliseconds. Let's look at the fault scenario. Is only 87% of requests pass, and therefore 12% fail, a ratio close to the 10% injected. And the average request duration is 106 milliseconds, reflecting the additional 100 millisecond injecting by the service disruptor. Now we need to look our services, look our applications. For this, we need to get some system metrics, and we need to get some K6 metrics, and then we can correlate these both metrics in the one place. You can use the Grafana, or you can use the New Relic for this. You can getting insights from these monitoring tools, and you can visualize how it goes in our application, and where is the failures, and you can analyze the results. You can getting some results from the these insights. Before we finish, let's take a closer look at the concept of failure injection testing through some different lens. I wanted to introduce some analogy in here. Let's imagine you have a RGB lenses, and each lens reflects different aspects of the application level. When we put the blue lens, it kind of represents the baseline perspective. However, this lens doesn't give us a clear picture of the applications on the true performance. Instead, it only shows us how the application operates under ideal conditions. This perspective can be misleading because it doesn't reveal any unexpected issues. Also, this lens offers a limited view, focusing only what we expect to see rather than uncovering potential problems that could disrupt the application's stability. Now imagine swapping out to the blue lens for a red one. The red one symbolizes the injection phase of our failure injection testing. When we inject fault into the system, we are essentially adding some layer of complexity and adversity. And the red lens reveals the chaos and challenges that application may face during real-world incidents. It's like looking the application through a lens distorts and disrupts its usual operation. And we see the impact of latency, errors, and other disruptions that mirror the actual issues that might arise. Now let's switch to the green lens. This lens symbolizes the outcome phase. When we test our application under the influence of red lens, we want to assess how well it copes with these disturbances. The green lens helps us understand the application resilience and recovery capabilities. It also reveals whether our application can adapt and continue functioning, or if it stumbles under pressure. And we see the responses and recovery mechanism that determine whether the application can return to the stable state, to the health state. Now, when we combine the insights of these three lenses, blue, red, and green, we are arriving at the final picture of the application reliability. This composite image show us not only how the application behaves under ideal conditions, but also how it responds to real-world disruptions and how effectively it recovers. Thank you very much. So we can jump to the Q&A session if there is any questions.
That's really an insightful session, Yusuf. I guess we are also receiving quite a few questions you in Q&A session. I'll just bring the questions on. I'll just put the questions on the stage, and maybe you can answer. Let me
Sure, yeah.
start with this one. I guess. Yeah. What strategies can be used to document and learn from the chaos experiments to foster a culture of continuous improvement? Mahesh is asking the question.
Yes, that's a good one. We are getting these chaos experiments like a culture in our company, and first we are giving some insightful some how can I say some after some experiments, we are presenting these experiments to our stakeholders, and we are documenting these things, these experiments, and then we are learning from them, and we are getting some sessions with the DevOps team and the other teams, and we are implementing these chaos experiments into our CI/CD pipeline as well, and we are adding some steps to do before the release. We are we are doing some experiments before the release, and basically you need to create some plans first, and then we need to determine the which uh, which components we will focus on the system, and then we can run this experiment, and then we can document and learn from these experiments. I can explain like this.
I guess that makes total sense. I guess this is a three-step process: plan, decide what you want to test, what you want to do with what
Yes.
components, and maybe then we can maybe simply document. That totally makes sense, Yusuf. We can move to another question. Uh, yeah, this one I guess I would also wanted to know. Though you have spoken about K6, can you also suggest some alternatives that are on or above at par with K6 browser?
Yeah, yes, you can use also K6 browser, but the K6 browser it's kind of focuses our front end application performance. We are getting some insights from the some core metrics for the front end performance. But when we talk about the failure injection testing, we cannot use the K6 browser. We need to use the K6 disruptor or as I said before, the Chaos Monkey or the lots of tools we can use the failure injection. It's all about which environment you are using. For example, if you are using the AWS, maybe you can use the AWS fault injection, or maybe you can use the GCP. You can choose the another tools for the failure injection testing. It's all about what you need what you need for the chaos engineering or for the failure injection. For
Hmm.
example, you can also use for the pod termination these tools. Also, we can use K6 disruptor as a pod termination. You can terminate. You have a 5 or 10 pods, and you can use the K6 disruptor randomly, terminate 20% of pods in the system.
Okay, okay.
Yeah.
Yeah, I guess I'm going ahead with another question. This I'm not sure it's but yeah, please go ahead and help us with that. Yeah, I guess three upvotes also. Ashima is asking, like, can you touch base upon a usage of chaos testing for the last industry project? I understand it's a huge question. It
Yes.
may take another session, but maybe we can address it in a minute or two.
Sure. Yeah. For the large industry projects, we need to carefully when we running these experiments, because you might broke some things in your environment, and you need to be carefully, and you need to work with DevOps team with closely, because uh, for example, if you're running these experiments on the test environment, you can block the test environment, and you can stop these all of these testing process, and we don't want to these things in the large industry projects. And if you have any chance, you can create a new environment for this, and it might be a great for us for the running these experiments. But if you have a strong projects, if you really believe your projects, you might run these chaos experiments in your production as well. But as I said before, we need to careful for these experiments. Yes.
Of course, that makes sense because these projects are huge, and I understand you wanted to.
Yes.
You have to put so many things into that 1 minute.
Exactly.
I guess I'll take one more question.
Okay.
It's something a staple. I guess I was expecting for everyone to answer. Like, how can AI or automation tools or practices uh, helps or hinder chaos engineering, failure injection testing? Like simply, someone is trying to ask how AI is placing in this.
Maybe we can use the some tools for the analyzing the results after the experiments. For example, you can use some monitoring tools, APIs, and you can combine with the AI, and then you can easily find to where is the problem when running these experiments.
Hmm. Okay. Okay. I guess we can take one more question, Yusuf, and then
Okay.
it's this too is an open-ended question. How do you handle data management for large-scale projects? Denise is asking if you can.
For this, we are using the also I will explain from our company perspective, because we are using for this data management. For example, we are generating data with K6 and daily basis. We also implemented our CI/CD pipeline, and we are running this K6 for the generating test data. And then like this, we are handling data management, like closing to the production environment, and we are generating millions of data with K6, and we are handling these data like production.
Hmm. Okay.
If
Okay. I
it's
guess.
answer, or I can, if you ask to the LinkedIn, I can answer in there as well, if you have
Yeah.
any
Sure. Sure.
questions. Yeah.
Sure. I guess I wanted to also tell everyone Yusuf is quite active on these platforms, and you can always shoot a question to Yusuf. I guess that's all, Yusuf. Anything you have to keep in mind? We have to keep in mind any last thing you want to say?
Good. Thank you for everyone for being here.
Yeah, I
Yes.
guess that's a wrap. Big thank you to Yusuf for the awesome session. We definitely picked up some valuable insights today. Just a quick reminder, everyone: these sessions are being recorded and will be available on Lambda Test YouTube channel. So feel free to revisit them or share them with your peers. Thanks for joining us, and have a fantastic day ahead. Bye bye, everyone.
Thank you very much. Bye
Yeah.
bye.